Hello everyone. Today I have come up with a problem from Neet 2025. Let's read through the problem once. It is related to surface tension. There is a water tank. It has one wall at x equal to L and can be taken to be very wide in the z direction. Z direction is perpendicular to the paper. It is going into the plane. When filled with the liquid of surface tension S and density rho, the liquid surface makes an angle theta naught, which is very small as compared to 1 with the x-axis at x equal to L. If y, which is a function of x, is the height of the surface, then the equation for y is. So, if we go by bilkul the first principle, in fact the surface looks like this. And this is the boundary, and the boundary is at x equal to L. And let us say this is the baseline. This is the x-axis. And then we take a strip at x and x plus dx. So this width comes out to be dx. This is x and this is x plus dx. And into the z-axis, let us say the length is z, which is very long. Okay. So this is the volume of the liquid. Now this volume will be supported, this weight of the volume will be supported by the weight, by the force of surface tension. So if we draw the surface, there will be two forces of surface tension. One will be acting like this, another one will be acting like this. Let us say the angle here is theta 2 and the angle to the left is theta 1. Now this force will be S into the length of the surface, which will be z in this case, and so the vertical component of the surface tension force will be Sz into sine theta 2. Similarly, the vertical component at theta 1 will be Sz sine theta 1 in the downward direction. And so the net force of surface tension will be Sz sine theta 2 minus sine theta 1, and this will be responsible for balancing the weight of that liquid in the column of width dx. Now the weight of the liquid will be rho g times the volume. Now the volume is what? The volume is, if this height is y here, the volume will be y into dx and into z. Z is into the plane of the paper. And z gets cancelled on both sides. Also, since theta is small, we can write sine theta 2 as tan theta 2 minus sine theta 1 we can write as tan theta 1. Angle is small, and that is equal to rho g y into dx. Now tan theta 2 is the slope of the curve, so dy by dx at x plus dx, and similarly tan theta 1 is the slope dy by dx at the value x. We divide this by dx and we get equal to rho g y. Now this term is nothing but the second order derivative. So s into d2y upon dx square comes out to be equal to rho g y, which gives us d2y upon dx square equal to rho g y upon s. So this is the differential equation of the surface, the curve, the cross section. So the correct option is the first option. So you can go through the problem once. This is a slightly mathematical approach. In another video, I will come up with another solution, which will be less mathematics, more physics. So I hope you like this. Go through the solution once. Thank you very much.